Okay, the goal of this video is to talk about how we can use the vector product to find the area of a triangle. So, but there's a bit of backstory to this, and it's a little complicated. I don't know that they're going to ask you to know this proof, but for those of you that want to know the why behind something, that's what I'm trying to do for you. Okay, so if I've got a vector A and a vector B, when I cross them, I end up getting this vector right here. So we could, if you want to pause the video and go verify that that's really true, remember we set up that matrix, that I, J, K across the top, and then it would be A1, A2, A3, and then B1, B2, and B3, and then we can take the determinant of that. It ends up getting us this, and for the purpose of not taking too much time, I'm going to just jump straight to there. So now if I want to find the magnitude of that cross product, I take each one of these terms and square it. I messed up, I'm sorry. I square this, I square this, I square this, I add them all together, I take the square root, and hopefully you're comfortable with finding the magnitude of things. Well, so then what they're asking us to verify, well, one of the cool things that happens is that the magnitude of the cross product is equal to the magnitude of one vector times the magnitude of the second vector times sine of the angle between the vectors. Okay, and so the proof that they give us is kind of cool, but there's a spot where you might want to pause and go see if it's true. I feel like, well, here we go. So what they do is they start with this side and they square both sides, okay? Which typically we don't do, but we're going to prove that the square of this is equal to the square of that, and therefore this is equal to that, okay? So they squared this, which means you square each term. And then we know from our Pythagorean identity that sine squared is equal to 1 minus cosine squared. So we plug that in, we distribute through, and then this right here, you'll remember cosine of theta is equal to the dot product divided by the magnitude of A times the magnitude of B. Oops, sorry. And so therefore we can say that, sorry, that A dot B is equal to the magnitude of A times the magnitude of B times cosine of theta. Therefore, if I were to square this and to square all that, these things would still be equivalent. So they went from here, which is this part squared, and they jumped to this, which then said, okay, well, it's the dot product squared. So, so far, I think you're on board. The magic happens a little bit later. Okay, so the magnitude of A squared, well, would just be A1 squared plus A2 squared plus A3 squared. We would normally take the square root, but we're squaring it here, so that square root is gone. B behaves in a similar way. And then when I have the cross product that's not the cross product. When I have the dot product, it's A1 times B1 plus A2 times B2 times A3 times B3. That's the dot product, and then I need to square it. Now what happens here is that you've got to FOIL all this out, you've got to FOIL all this out, and you get a whole lot of terms, and it gets really, really messy. And I feel like I've done this in past years. I don't know if I did it in a video. I don't know if I did it and just scanned my work, but I'm going to go look and see if I can find that for you. You don't have to do it. There's just, for those people that want to know the why behind stuff, when you expand all this out and do all the algebra, it comes down to this, which we will recognize, well, that looks familiar. This is the magnitude of the cross product squared. See how that matches, assuming I got all my numbers and letters in the right spot. Okay, and so this is the magnitude of the cross product squared, and so now if this squared is equal to this squared, then therefore we can conclude that the cross product of the magnitude of the cross product of A and B is equal to the magnitude of A times the magnitude of B times cosine, I lied, times sine of A. Okay, so let's think about this for just a second. Let's say I've got a triangle that's formed with vector A and with vector B. And so here's that other side of the triangle, and this is my angle theta. Well, what happens here is I know I can find the area of that triangle by saying 1/2, well, the magnitude of A times the magnitude of B, hang on, so sorry, times 1/2 AB sine C. Well, C in this case is that angle theta. Okay, so what I can do is I know that this part right here, we just said that this is equal to the magnitude of the cross product. So I can say that the area of a triangle is equal to 1/2 times the magnitude of A cross B. Okay, which is pretty cool. So let's say that they give us, this allows me to have two vectors, or say I have 3 points. Let's make up something, I don't know. Apparently my paper got too close to my iced coffee. You know, living it up in the time of Corona. Okay, sorry, just kidding. Not funny. Okay, so let's say I've got point A is, I don't know, 1, -2, 0, and point B is -3, 1, 2, and C is, I'm making something up, 2, I don't know, -1, -1. Okay. So I can, if I want to find the area of this triangle, I can look at I can find a vector AB, and that would be B minus A, that's -4, that's -3, 2 minus, make sure my arithmetic is correct. The problem with these is that it's really easy to not catch your mistake. So this is AB. Let's look at AC just for the fun of it. We could find another vector. It doesn't matter a whole lot, but here's vector AC. So 2 minus 1 is 1, -1 minus, so that's a +1, -1, okay. So I want to cross these two vectors. And this is a nice little reminder of how we find the cross product. -4, -3, 2, 1, 1, -1. And so if you remember, it's I times, we'll cross out those, it's a -3, it's a 2, it's a 1, it's a -1. Sorry. Okay, and then it's minus the J, -4, 2, 1, -1, and then it's plus the K, -4, -3, 1, and 1. Okay, so that's 3 minus 2 is 1. This is 4 minus 2 is 2, so that's now a -2. And this is -4 minus a -3, so -4 plus 3 is -1. And so this vector is the vector 1, -2, -1. And so what they're telling us now is that that the area of this triangle that would have been formed if I close that off would be equal to, the area of the triangle is equal to 1/2 the magnitude of those vectors, AB cross AC, which we've already done. So it's the magnitude of this vector. So this is equal to 1/2. That's 1 plus 4 and 1 is √6. And so the area of that triangle is 1/2 √6. Whatever my units are, they're squared. Okay, so that's what we want to practice. I hope that made sense. I'll go see if I can find the connecting piece. I don't think I'm going to be able to do it again today. So if I don't find it, I'm sorry. It's a nice exercise for you to practice. Good luck!